Hey, didn't see you there. We're about to do an instructional video to find out different P waves and S waves through different types of rocks.
Okay, so these are the materials that we're going to need for measuring the P and S wave velocities through our rocks. And so this is our waveform generator. It does exactly what you think it would. So it generates a wave that we are going to send through the rock. And this is a sound wave that we're going to be sending through the rock. Next, we have our amplifier here, and we only use this if we're having trouble getting a signal through the rock. It boosts up the signal. That helps us see it. And then we also have our oscilloscope, and the oscilloscope will measure the wave that we're sending through the rock. And we can use it to determine how fast the wave has moved through the rock, how long it takes to get from one end of the rock to the other. Then we also have our transducers. And so we have two transducers here. One connects to our waveform generator, the other connects to our oscilloscope. And these transducers will connect to the surface of our rock, and they will send the waves through our rock so that we can measure how fast it travels through. And we will also need a clamp to stick the transducers onto the rock, and we will also be needing some honey to help it stick, and popsicle sticks to use for the honey.
Okay, so for this experiment, we'll be needing a couple of coaxial cables. So we have one going into input 1, and that one is connected to one of our P-wave transducers. One coaxial cable is connected to the trigger, which goes all the way back to the trigger in on the back of the oscilloscope. And then we have another one going from output 1 to another P-wave transducer. And this one acts as the receiver, and this one acts as the transmitter of the wave. Okay, let's start with the waveform generator and turn it on. Almost there. Okay, so we're gonna want to send a 1 pulse signal through. So we have our wave set to 1 megahertz, the highest amplitude. We want to hit burst on number of cycles 1, to send 1 pulse through. And then we hit the trigger button, and that should be on immediately on channel 1, because we are going from channel 1. You can hit auto scale on the oscilloscope to see what your setup is set up properly and see if that will scale it for you. But one important thing to know is to trigger it from external, because that triggers it from the function generator that we just set up. There's lots of dials you can fool around with on the oscilloscope, like the vertical adjustment and the time adjustment and horizontal. Lots of fun buttons.
So we want to measure the seismic velocity through rocks because every material has a different seismic velocity, and that can tell us a lot about the different kinds of materials that we're dealing with. And if we want to measure the P wave or S wave velocity of a rock, what we will need is we need a sample with flat sides, because we need the transducers to have a smooth surface to adhere to. And so we need flat parallel sides on either side of our sample. We need 2 transducers that are perfectly in line with each other. And so if we have our nice flat sample, then we can take our two transducers, our transmitter and our receiver, and we can place them in a way that they are perfectly aligned with each other on either side of the rock. And if you need them to adhere to the surface of the rock, you can use honey and put some honey on the surface of your transducer. And then once you have that done, you can place the transducers like so, and then you can get your clamp here, and you can...
Wait, I was supposed to put the clamp on.
No, what do you...
Let me put... You hold the rocks.
Yeah.
And I'll put the... No, wait.
Yeah, but
I put the...
but we need...
I'll hold the transducers on.
Yeah.
You put the clamp on.
Yeah, but we need someone to... Okay.
Okay, you'll need a little bit of help to put the clamp on the rock with the transducers in place. So select a rock, put them on either side. Clamp, please. And there you have it. Rock. Alright, so this is what we got. We have our rock. We have our two transducers clamped on either side in parallel with each other. And now we are ready to record our wave.
Alright, so once we have our whole setup done, like we've beautifully done here, then we can go to our oscilloscope and look at the waveform that we have coming from our rock. So this is what the waveform looks like from our wave traveling from our waveform generator through our rock and then to our oscilloscope. And so what this can tell us is how fast the P wave, this is specifically our P wave, how fast it was able to travel through the rock. And so what we can see is that here we have time 0, where you can see this little orange triangle. And then what you can do is you can locate on the time scale where the first arrival of the P wave is. And right here, it's about 7.5 microseconds. And so that tells us that it took 7.5 microseconds for the wave to travel from one edge of the rock and the other. And we can use something like a ruler or a caliper, if you have it, to measure the distance across the rock, across the transducers. And then you can use your distance divided by your time to get your speed of the P wave through your rock from this data.
Alright, now that we have a good waveform, we can reference it. So we can choose another rock and then compare waveforms. So I'll hit the button up at the top here, sources, reference waveforms. So when I hit R1 is on, we can save this reference to R1. So this waveform will match the R1 wave. And now we can hit stop. And then that orange wave is our R1. And then now we can connect another rock and see how that one lines up with R1.
Alright, so we've set up our new rock. This is some aluminum, before we had some granite. And so now we have it stopped, our oscilloscope, and so now we're going to hit run, and we should see that new waveform in relation to our old one. Okay, so... Alright, so we can see we have two waveforms here. So this first one in orange, that was from the granite we were looking at just earlier. And now this yellow one that we're seeing is from that aluminum that we have on right now. And so you can see that the yellow one is showing up faster, or is showing up earlier than our orange one. And that's because the P waves are going to be moving faster through the aluminum than they are through the granite. And so having these reference waveforms can show you the difference between two different materials.
Well, there you have it, folks. A rock instructional video. Velocities. Back here you go. Good night.